Were you in that group?
No.
Oh, okay. Other groups? You said D. Like that?
I think so.
What did you say? The other one, they changed it? Oh. Did everybody, did each of them have one of these? Yeah? All right, let's talk through, let's figure it out. Which one's right? So someone, you were all involved with it. Give me at least two first. This we're gonna go there and then back. Go.
You can start B and just find the net force and should be right.
That's a good plan. Let's start with B. Easy, right? Okay, so net force on B. Now hold on, I'm gonna back up. Because that's the question's asked. Is and you're telling me about my net force. Why?
Well, because if you find the force and put the force in one direction, then you can find the speed after.
I agree, but we haven't come. So you're telling me you want to find the net force?
Yeah.
Why?
Because if you find whichever is the biggest net force on that.
Okay, that makes me happy. So the net force is going to lead to acceleration. The bigger the net force, the bigger the acceleration. So what? That's not the speed.
So then after 2 seconds, it'll have the highest speed.
Does that make sense? Okay, so if I was going to grade this as really picky, and you're reading this part, then it would be completed. Do you see what I'm saying? And again, I'm not going to be stuff out. Right? We're trying to. So I want you to know that. So you have to say something to this effect. This would be good, but we're talking. So okay. So the goal is, I think what we're saying is to find the net force on each of these.
Yeah.
Okay. And you said you want to do that one. You got 10 moves flowing to the left. Right? And do we care about the direction? Why not? It's not a vector. So all I really care about is okay. All right. B is done. I don't really know where to put it yet. I don't know really anything else. Okay. Pythagorean theorem. So what did we get for a value for that? Can somebody put it quick so we can compare? So for this one, you're gonna like add the vectors together just so this way. Is this okay with everybody?
Yeah.
So f net is going to be like the square root of 10 squared plus 6 squared. Square root of that, yeah. So what did you get? 11 point something? Like 11.7-ish? Okay, so B and D are done. That leaves two more.
Well, then with
Yes. Okay.
you can find
Okay. Resultant. Does that make sense? Yeah, speak. That's true. Do we know what the value is going to be? Something. 7.0 something. Okay. But they will definitely be the same. Okay. Excuse me. So now, what do I do with that information? Somebody, I don't know because I love it or because I want to share the fun. What am I going to do with that information now that I've broken it into pieces? The net force of the horizontal, so it's going to be 7 minus 6, so it's like 1 that way. Okay, so I've got something like 1 in this direction-ish and 7 in this direction. Something like that, right? So then can I find the net? Yeah, what if we get when we do that? You guys go through that? Do you want me to help you with that? complicated. If it makes sense.
You use
Where are you getting 6?
okay.
That's okay. Those are funny. How are we doing? What'd you get, Jenny? If this is 7, then I can't be 3. True? So
7.07.
7 point something something? Yeah. 7 point, what'd you say? 0.7. I will say that we did round because I. Okay. Thank you. Okay. Let's do It's not 6 times as big. Yeah. Because
Yeah, that's right. That's okay. My
how are we doing? Are you working on this with your table mates? That corner table, where's that going?
because you self unforced. You have to find out the horizontal. Go this way.
And you should.
Alright, I'll show you. So 6 and is the project. Alright, so there'll be 7 off points.
It's close, but not quite. All right, my friends. What are we getting for C? 7.15. So,
Wait, how did you find it?
same way we did with this one. So, we're going to break it up into the pieces, right?
So then you'd have sign.
So, 6, 45.
Yeah.
And subtract that from 10.
Oh, that's. So wait, did you get like for that and then? I don't know.
Oh. So, cosine 45. And if I subtract that, the up part.
So you have 5.75 going like horizontally. Got that right.
4.2.
Okay, that's gotcha.
What's our
Like
it shouldn't matter. And you need to make sure the way that the tree works out, these are actually equal. Okay. Does that make sense to everybody? Yeah. It's not intuitive. I wouldn't have guessed that that was the case. Just kind of staring at the question to start. It's the same process. Right. Once you know the answer, it makes sense. There are more of these to come. So last time we were together, I kind of feel like maybe my computer wasn't working or something, so I wasn't writing on here, which means that I don't have a record of how far we got. But I think we were on this problem, weren't we? One of the two boxes. Yeah. And just how far we have gotten. Okay, so now no. Okay, all right, now I know. So to get our brains back in here, I just want to remind you and draw the picture on two boxes that are connected by a cord and then being pulled in this direction. Does this sound person on the box A? Well, I just want to make sure you had this and this one is box B. Okay, fantastic. And this one is 12, right? And this one is 10 kilograms. Okay. And that force is an applied force, and it was. Okay. And they did. Yes, let's do that. No, we should. Thanks for catching that. Okay, so life is okay so far. There's gravity and normal forces. Do you agree with that? Yeah. That because that's just so we can kind of simplify. Okay. So then you want to know the acceleration of each box. So at the end, I do remember this conversation we're having now. We're on a surface, and the argument was that these two boxes will accelerate at the same rate. Is everybody okay with that? Did you like wake up last night like okay? Okay with it? Okay. So if we say that they accelerate at the same rate, the beauty of that is that we can pretend that instead of having one or two boxes, we just have one really long box. Right? Oh. The lovely thing about that is that then we only have one force. Right here? Oh, that's nice. We have one big box that has a mass of how much? 22.0 kilograms. Can you figure out the acceleration of that box? There you go. I believe in you. Do it. I would start with an F net equation. It would be a very simple one, but start there every time. And now it stuns me if you talk to me. So do talk to me. How's it going? Bless you. Okay. Everybody's happy here? Part A. Part B says find. You know. And a piece of string. just play with box A first. Do you know the acceleration on box A? What is it? Accelerating in the x direction. How many forces are acting in the x direction on box A? One. Can you figure out what that force is?
Yeah, that one.
Yeah. Can you figure out what that is? Let's figure out how big it is, though. So if we look at the F and A on A, so this is just talking about A. The only thing that's acting is the force of B on A. And is that causing our box to accelerate? Yes. Yeah. Question? No, I'm just trying to reiterate them so that we get them stuck in our brains here. Now, what mass is that? What mass are we going to use? 12. Mass of A. About A stuff. Mass of A, B on A, which is the mass of A times the acceleration. I'm going to put an A. Right? With just some simple multiplication, you should be able to figure out that force, yes?
Yes.
Go. What'd you get? Units are? Newtons. Okay. Are we okay with that?
We should be getting 4.
What's that?
Should we have the 4?
Probably not.
Yeah.
I was trying to be, yeah. Let's get rid of it. There you go. You're a 4 hater, Addison.
Hate it.
Hate it.
So much.
Okay. So that wasn't hard, right? Now, I'm going to figure out the force of B on A. Well, I hope so. Theoretically, yes. Let's prove that it is. Because that's going to satisfy me more than just, like, no, don't ever believe anything I say. That's, oh, it is. Thank you. Thanks for catching my mistake. I don't ever make it. I'm okay with that. All right. So let's write an F1 equation for box B. What forces are acting on box B? A on B. On B, that should be a B. Like I said, I never make mistakes, right? Oh, of course not. And what mass am I going to write there? Yes, which is the mass of B, yes. I was like, whoa, where did that number come from? Are you okay with this?
Yes.
Okay. Now, you may already, it's only about like the 14th day of school or something like that, or like 12th day of school, whatever. You might be tired of me already saying, like, you must draw 3 every time. Every must bring every time. But I'm telling you, you must. Because it's going to be really bad if you don't. This is helpful because this is the only way that it is accurate. Right? And that's where it's not equation, I would never worry about that. But without this, it's really hard to guess what this is. Especially when you're talking about going in different directions. These guys are going in different directions without the statement. It's going to be confusing to keep track of the positives and the negatives. This is all happening and straight for you. Okay? Which way is F, A, and B going? To the left. So I'm going to call that the negative direction. So I'm just going to rewrite this with negative signs. F, A on B. What about FP? Is that going in the positive or negative direction?
Positive.
Positive. So I'm going to leave that as positive. And then I've got MB sub A. And is that going in the positive or negative direction? Positive. It's accelerating that way. So now I need to solve this for FA on B. Right? That's what I want to figure out. Some of us think maybe it'll be that. Let's find out for sure. Like, oh, yes? Is that what it is? So, yeah, I guess. Yeah. Okay. So I want you to solve for FA on B. And then when you get it, you can say, I'm saying is you need to make sure you pay attention to those negative signs. Because if you don't, bad news, friends. It works out? Oh! You didn't believe me, not because I said it, but because it's true. Now and then. How about that? What did you get for FA on B? Oh, see that. Good job. Good job. Was that weird and scary? Or was it okay? Okay, but you feel better about it now? Like maybe a little confident? Like a little more confident? Well, good. Okay. Can we move on? Okay. A little conceptual question. This is terribly and thought-provoking and practical. And really the practicality is what I'm looking for. All right. Your little sister or some other small person or maybe I will tell you that it is not on either there is discuss at your table. I will tell you that
Well, I mean, look at the position on these. I mean, probably it's more practical than this whole. That's not.
so put some more physics terms to what you said. Okay. And right? Do you remember? Okay. So the force of friction is really the surface of the mass of the object. Because oh.
Bigger.
Down the table, whereas if I pull them up, I'm holding them back. But also, I'm decreasing and adding a little bit of force to that direction. That means that I have to pull. Okay? Alright. So, mystery box. Today may very well be the last day of mystery box problems.
Oh.
I know. I kind of think maybe I'll have to write some more for you. Some of you are not so sad. I don't know why. They're not that bad.
Are you gonna write Marcus problems?
Maybe. We'll see. All right.
Oh boy. Oh.
It says the coefficient of friction is to find the acceleration. Yes. Discuss unless I tell you to. How about that? Yeah. Good idea. Oh, thanks for asking. So it's like that. Does that make sense? Yes, you are. What a nice thing about the three-way diagram and equations is if you're presented with a problem that seems really hard, impossible, really confusing, a really good place to start, right? It helps you to write down some things, gets your brain thinking in the right direction.
Everything. You can break it down. Here's pretty good.
How are we doing, your friend? We're getting there. Look at this. Where's my heart? Beautiful thing. Tears are flowing. Thanks. If I would have rated it,
Not
Let's do again. Woo.
No, you're close. Sorry. It'd be like negative 98.1. Everybody. Oh, yeah.
All right.
Should have said, oh, I'm gonna make it.
Yeah, of course. I'll make sure I'm like. Most of the episodes I wrote down, half this, I just find it easier. But if you want to write FP1, FP7,
When you know the yeah. Huh? Well, break it into a no, it's 34 minutes. Class is the force of action. That's the action. And then the Y one is just your Y.
so FF is equal to mu times FN. So the only way to get FF is to know FN. Does that make sense? Which is why I have to have that FN. Yeah.
It's not accelerating.
So use, so you know FN and you know. From those two, you can find that. Is that okay? You okay? Okay. So we find our own course? Good. Good. That's the right answer, but.
I hope it is.
Me too.
If it's right, then I enjoy it.
Yeah. Acceleration.
No. No.
Okay, well, that's nice for me.
Mu.
Normal. Normal.
Next level.
That's the
Yeah. Yeah.
G.
Well, yeah. Not yeah.
How can we find G times the force?
Acceleration.
Acceleration. we know so now
Yes.
and those two go the same direction. We probably all right. So so I would probably write F and Fn goes upwards, right? And it goes up, so I'm going to add that. And does Fg go up or down? So I'll probably say that's negative Fg, and that's equal to 0. So then when I solve for Fn, so Fn is equal to Fg minus Ft sine theta. Is that okay? Because it started out negative over and then over here. Yeah, yeah. So what did you get? What value did you get for Fn? 78.1 is what this says. Is that okay? And so then I'm going to plug that in over here, and I've got my Ft cosine theta. I've got so I have Ft cosine theta plus mu times 78.1. Are those going in the same direction?
No.
No. Which one's going in the not farther direction?
Friction. That's friction. Force of friction.
This one. So I'm going to make this negative. Is that okay?
Yes.
Again, these are the little things you really need to pay attention to, because if you don't, then it's like I feel like I'm threatening you. I don't mean that. I'm just warning you. And then to solve for a, we just divide by n. Do we get a value for a? 1 point something?
So mu is like the 0.30.
Yes. Yes. Units are?
Yay.
What's up?
You can't be here.
No. No, mu will always be positive. Because it's the ratio of two of the forces. And those forces, the magnitude. So that will be positive. And as long as you put your negatives and positives in, okay. You don't need to think about, like, how's it going, friends? Are we doing okay?
Why is it? Why? With the how many? Right now,
But units wise, like, where does it come
yeah,
from?
like because those have to be also be. Oh wait, sorry,
Okay.
yeah.
Okay. Anybody else want me to say? Okay. Yes, it would. It would be hard to not function.
Yeah.
It would be hard to function. Okay. I'm gonna throw something at you. Okay. Right. So there's okay. So good right there. Yeah. All right. Mr. Box. Oh yay! I don't think we played with this in Unit 1. Correct me if I'm wrong. Did we play with this stuff? Okay, so this some of you this idea of a one. We stuff. I actually felt but I'm very particular about the way that I would encourage you to do this. So I'm going to
Yeah.
all right. So we're on an incline plane. Okay? Everybody know what that means? It's a ramp. Okay? I told you it's gonna be big. Go ahead and do it. A rough 30 degree incline plane. I'm gonna draw mine a little bit bigger than 30 because it helps to. Kind of. That's not quite the point, but it is. All right. So I'm gonna put my mystery box on the incline plane. You guys do the same thing. And part A, and actually part C, really all are just so let's start right away, shall we? Okay. Of course, acting on the box. So FG. Where does that go?
It goes in the box.
Perpendicular to what?
The dotted line.
The dotted line.
There
So
you go.
horizontal. It's straight down, right?
Yeah.
The center of the earth. Let's do it. I'm gonna draw that really large. There's one in here right now. So it's gonna be the force of the earth on the box. In parentheses, I'm gonna remind myself of G. And to make it easy, I can only draw it on the left side of it.
Force of the surface on the box.
Force of the surface on the box, where's it going?
Perpendicular to the surface.
Perpendicular to the surface, and because it's perpendicular to the surface, that would lead you to believe that's a
Oh, normal.
normal, right? Normal means perpendicular. All right, here we go. So that's going to be the force of the surface on the box. It is perpendicular, so that reminds us that it's a normal force. Fantastic. Now, I'm going to pause us there for just a minute. If those are the only two forces acting, would this be at rest?
No. You know,
There's got to be a force of friction, right? Force of friction always goes motion.
parallel.
Parallel to the surface, because it always is, but not parallel, tell me more about it.
An angle of 30 degrees.
To the horizontal, sure, yeah. That's true. Life is okay? Okay. Now, wait a three-way diagram. A, B, T. Okay. Part B says, is that okay? Or I'm sorry. I just shouldn't have interrupted your thought process. Are there more forces? No, friends. You happy? Okay. Tell me, like, I'm like, there are more forces. Yeah, it's,
Parallel.
just parallel. All right. Part B says, box worse like. Let's say the box is sliding down the ramp. How is
The force of friction.
it? Okay, so tell me what it is.
There's a certain, there's a certain oomph you have to get past. Or you can start going when there's friction. Once you get past the force of friction. How we do it? I don't know. Yeah.
The static friction kinetic friction there? Okay, so in the picture, how would that
Force friction.
okay, so that will fall. Yeah, what did you okay. So what is power?
Yeah, because at the angle of 30 degrees.
Yeah?
And so there's a force of gravity pushing it and the there's an extra. Yeah.
I have that. agree with that? Gravity, the gravity. Yeah,
Well, force of friction.
Yeah.
Wait, is it still going up that way, or is it starting? Or would it stop? Well, then, yeah, the friction's what friction would cause?
Because there is an initial shock. So there are. D. If the box weighs 150 newtons and it's just barely not moving, so we're talking about part A again, what is the coefficient of friction between the box and the surface? Wah, wah, wah. Close to 1. Thanks. Let's figure out what the value is. How do you find mu?
It's force of friction on the
So in order to figure out mu, you need to know the force of friction and the normal force, yes? Okay. So we have to do some stuff. Do you agree? We need to calculate those. I'm thinking you guys kind of now, we could also, there's an option to break this one and this one.
That's more work.
But then we'd have everything nice and nice and white. Just like question. Wouldn't that be nice? X's and Y's? We could, just like this, right? But
Feels like
I don't even feel more. Yeah, but I don't want to call it something not. So let's not call it something it's not. Let's call it something it is. There's no X anymore. FN, N for what?
normal.
Normal. Normal means what? Perpendicular, right? Always be perpendicular to the surface. Always going to be what's the surface?
Parallel.
Oh, those are the. I'm going to call them perpendicular. Okay? It takes no more work than X's and Y's. It's 2 lines and 2 lines. So no big deal. It's going to be more accurate to describe this way. If we do that, then we need to break FG into its perpendicular pieces. So it's going to be part of this. I'll call that FG perpendicular. There's going to be a part that goes like this. I'm going to call that FG parallel. Okay? Now, word of warning. I often have students that when they start drawing the components of this, they this the hypotenuse. That defeats what we're doing. So you need to remember, if you're ever bringing the force into balance, the original force has to be the hypotenuse. Right? Otherwise, why are you? All right. I love that I missed this and I subject you to geometry. Okay. It's a triangle. What kind of triangle?
36 and 90.
I don't want to know it.
Right triangle.
Right.
It's a right triangle.
Yeah.
And that's horizontal. So the reason there's 90 generalizes. 46 degrees. 36. You know, generalizes. This right here is also
Oh.
that this says all three of these have to add up to 90. What?
Oh, okay. So now we don't have to make that calculation every single time. Yes, it is. Glory.
But
Oh. So,
you should to do
yes. Right.
You gotta do it. Bless you. Pay attention to what this says. This about waves. That is FG. Yes. Because that's the force already. Is that okay? Is that great? Going the
Oh, okay, gotcha.
How are we doing? Five eight.
Yeah. I like that one.
It's not moving. Not accelerating.
No, 60.
Not moving. And unfortunately, it's time for my accelerated physics friends to join me, which means that